solar system. Okay, so who of you guys know what a star is? What's a star?
It's a massive ball of gas that gives off light and heat.
That's perfect. Perfect. So it's a gas, very big amount of gas, which is contracted by gravity and emits light. It brights, we say. Okay. So the important thing is that it emits light. So this means that if I have a powerful telescope, radioscope, whatever, I can point in the right direction of the sky and see it, okay? Even if the star is very far away, let's say light years away. Yeah?
A light year is how long it takes for light to reach us.
That's correct, that's correct. So, the thing I'm gonna ask is tricky. So I'm gonna ask, what if I want to look at a planet? Can I do the same thing? Like take out a telescope, point in the direction of the sky I think the planet is, and look. No, why?
It doesn't give off light.
Bravo, bravo. It doesn't give us light. So because the planet doesn't bright. But actually, we are able to see this. These are the planets that are inside our solar system, okay? And with good things, with good telescopes, even Galileo was able to see some planets, the bigger waves again. But this is not enough, of course. Do you think that I can publish a paper and say, oh, I discovered a planet with this? No?
No.
Why not? But cannot.
It could be an asteroid.
Oh, that's good. Can be an asteroid. But even asteroids, not all of them, but even asteroids has a period of revolution. So what I was going to say is that this thing could be even something more silly than an asteroid. Could be like a bird that was passing by my telescope and doing this. This is the signal I can take when a bird passes by a telescope. So I said something important a while ago. I said a period of time. I'm gonna ask you know like okay, you guys also. Okay, Josh. This experiment is nice for them, but not for you. I'm sorry, but you are volunteer, so it's okay. You made for science, okay? Okay. What I'm gonna do? I'm gonna turn on that light. It's very bright, so I ask you not to turn and look at it because it's not good for your eyes. Also for yours. And what you have to do is very simple. You have to stay in this position, still. It's okay. No one is gonna beat you. I promise. Your hands here. Okay. Okay. Stay still. No one looks behind. Okay. Okay, Josh. A couple of seconds. It's gonna be over. Don't worry. No one is gonna beat you. I promise. But stay still. Okay. Okay, you can move.
Oh, wow.
Aliens!
Peter
Alien
Pan.
of my shadow, wow.
Okay. Thank you, Josh. Thank you. So what happens? Do someone of you knows what happened?
No.
No?
He lost
Ha perso l'ombra. What happened? Ah, you wanted to do. No, it's just once. I'm gonna say, no, I'm sorry. So I ask you, if you knew what happened. What happened? It's very simple, actually. I think you all know this. It's called.
Carbon printing? Carbon printing.
No, too hard.
Sorry.
No, this is simple. It's called fluorescence. You know? Fluorescenza. Yeah. So this thing is not a normal paper. I mean, it's a normal paper, but it's something on it. It's called fluoride. You know fluoride, fluoride. So this phenomenon is simple to understand. So I turned on that light, which is a source of energy. This energy comes in photons, which are the particles of light. So these atoms are particular because they absorb the photons. And as you know, the atom is made of a nucleus and electrons that go around. So they absorb this energy, and one of the electrons goes up in energy. When I turn off, what happens is that all these atoms are in a more energetic state. So after I turn off, they emit light, they emit energy with a photon. It's just a photon. Every atom emits a photon. So here there are many atoms, so you see many photons, you see like a continuous green light, which we say it's monochromatic, okay? But what Josh did is stay here, so the part that he was covering wasn't reached by the light. So these atoms weren't like excited, so they couldn't emit. So you saw like the shadow, okay? But there's no magic here. It's just fluorescence, okay? Thank you, Josh. We can go outside.
Come minimo lo vogliono comprare.
That was big. Also this one. This one big. No, I'm not going to touch.
Why not?
Okay, so now it's okay. So what happened? Yeah.
It builds up static electricity.
Okay. This is static electricity. Okay. What this thing created? Se lo attacco e lo tocco, prendo la scossa. Non lo faccio. So what happened here was exactly the same thing that happens when you see a thunderstorm outside. So this thing, for this reason, because there is this thing that goes away, it's like that experiment you did at the school with the pen.
Ah, sì, lo conosco.
Yeah.
Se sta finita per le lunghone e poi
Exactly.
prendi...
So mechanically, we take off charge from here. What kind of charges? Electrons. We take off electrons. So at the end, this thing is positively charged. And if this kind of charge is enough, is big enough, and I put this close enough to this thing, since this is neutral, it takes some electrons from here. So there is like the thunder, okay? It's exactly the same thing that happens with the thunderstorms. But this is not as strong as the thunder. I don't die with this. With the thunder, it's kind of... So I'm gonna show this one, so you can move and come here. Okay, yeah, you know this. So I think you all know this. This is called plasma ball. Okay? So let's pull all this direction so you can see also. I will move this a little bit here. Okay, I'm gonna turn on.
Wow.
So what you're looking ora lo tocco io.
Cooler in a second.
What you're looking at is a plasma ball. So what's inside? That thing, that round thing, is called bulb. Okay? That thing is creating an electrostatic field just as that one, but a little bit stronger. It's strong enough to, let's say, ionize the gas that's inside. What is ionize? The ionization is a phenomenon where if there is a very powerful field, this field can take off one electron from these atoms that is inside. Inside there is not air, there is a noble gas. Okay? So when this electron is taken off, we have an electron and an ion, which are charged particles. And charged particles see the field, so they go in opposite direction. And the color of this filament depends on the kind of gas that he used. So he said, "Can I touch it?"
Yes.
I'm gonna touch it. You're not gonna touch it. But you know what happens. This is what happens.
Yeah.
So
Non fa male.
non fa male. Doesn't hurt me. But actually, what is happening is that my finger is getting hotter, hotter and hotter. Now I take off because I don't like it. What's
Il
happening
dito si
here?
riscalda sempre di più, sempre di più.
I'm actually closing this circuit, so there is actually particles, charged particles that are passing through my body.
What do you think about if you go like you have your hand on it?
Oh, it's not good. Because I took them off. You saw this? I took some of them. Yeah. So, I mean, you don't have it. Because I took them off. Le prendo tutti sti filamenti. Mentre se metto solo un dito, vedi? Alcuni, esatto. So, what happens is that there is electricity. I mean, there are charged particles that goes through my body. I'm not feeling bad because it's not that intense. But what happens actually is that if another completely different thing, if I take this on for days, let's say 4 or 5 days, what happens is that a very thin layer of ozone creates around it. You know what's ozone? Ozono? What is it? Cos'è? Perché sta passando della corrente attraverso il mio corpo, però toccando per primo solo il mio dito. Siccome la superficie è piccola, si riscalda, ok? Si chiama effetto Joule. Oh, and ozone, we think it's very good. It's actually very good when it's in the stratosphere. It scares from the UV. Okay, exactly. But here, when I breathe ozone, it's not very good for my body. Okay, so ozone is important, even if it's just oxygen, but it's another kind of oxygen, O3, okay? So O2 is okay, O3 is not okay. Okay, so very last room, I ask you to pick